Okay, we're going to be working on section 2.4 in your book. You have these notes from Wednesday. Please get those out. In addition to these notes, you're going to need your calculator, because there's some calculator questions, and your formula sheet. So have your formula sheet out and your calculator, and we're going to be using those two things while we complete these notes. So follow along, fill in the notes with me, and these will be your notes for section 2.4, and your homework of just a few homework problems from section 2.4 that will be due on Monday. Remember, you have a test next week on Tuesday. So we'll talk about the homework problems on Monday and do a little bit of review and test Tuesday. Okay, so now our notes, if you're following the book, if you want to use the book also, we're starting on page 161. Okay, we're now moving our topics from types of velocity and specifically saying rate of change to what's called marginal analysis. And marginal means nothing but the rate of change. If you see the word marginal, you know you're finding the rate of change of whatever the next part of that function is. Rate of change are the words that mean take the derivative. Okay, so before we can start anything on this, let's get a couple of these notations down where we understand what they mean, because these are notations you're going to be using the rest of the semester. So from your formula sheet, find C of x, R of x, and P of x, and put the names of those in these blanks. I'll give you a few minutes to do that using your formula sheet. So from your formula sheet, C of x represents cost, and I believe it says total cost. I need to include that. R of x represents revenue, and P of x represents profit. So you need to know the names of those functions. All right. Now, so what do you need to write the revenue function? So here's the revenue function. Revenue is income that depends on the number of items sold and the selling price per item. Well, X is always the number of items sold or produced. In this case, we're going to say number of items sold. And then the price per item, let's see if we can find that in this column, is the selling price per item. So the revenue function, we need number of items sold and the price per item. What do you need to write a profit function? All right, so profit is, on our chart right here, profit is the difference between the revenue and the cost. So we need revenue and a cost function. In business applications, marginal represents rate of change. Marginal means rate of change. Rate of change means to take the derivative. In calculus, we say differentiate. It means we differentiate. So when you see C prime, that's just not the derivative of C, it means marginal cost. So notice that we changed the words from rate of change of cost to marginal cost. R prime is not R prime, it's marginal revenue. And P prime is marginal profit. Okay, so a couple of items that they discuss when they ask you questions, or you're doing some analysis, remember? And total cost is producing X item. Total cost of producing X plus 1 items means you plug in that next value. So this next question kind of walks us through a couple of those discussions. Turn the page, and you want your calculator out. All right. If C of X equals 225 plus 2X squared, find the cost of producing 10 items. So you're going to plug that into your calculator, or you can go ahead and just do it in your head. And we know that's going to be 425. Find the cost of producing 11 items. So that's 225 plus 2 times 11 squared plus 242, and that's going to be $467. So what's the difference of cost between producing 10 items and 11 items? Well, it'll be the difference of these two total costs. 467 minus 425 is going to leave you with 42. And we know this is referring to dollars. Okay, let's find the derivative. We're going to find the marginal cost. The marginal cost is going to be the derivative of the cost function. So the marginal cost is 4x. Find the rate of change of cost at 10 items. So that means find value of derivative at x equals 10. So C prime of 10 is 4 times 10, which is 40. So after 10 items, the cost to produce the next item, the rate of change from the 10th item to the next item will be $40. So what will it cost to produce the next item? The rate of change after the 10th item produced will be $40. So it will cost $40 to produce next item. So C prime represents how cost changes from X to X plus 1 items. C prime represents how the cost changes. All right, so go to page 162 in your book and copy the definition for marginal cost in this blank. I will give you a few minutes to do that. Marginal cost is the rate of change of total cost per unit charged in quantity change in quantity X. All right, so on to the next page. A specialty item manufacturer determines that the cost of producing X ballpoint pens is C of X equals 500 plus 3X. Find C prime of 100 and describe what that means. Okay, so first let's find C prime. C prime of X is equal to 3. So C prime of 100 is still going to equal to 3. So the cost to produce the pens is constant per pen. So it's going to cost $3 per pen to produce the next pen. So what's the increase in price to produce 101 pens? Well, if it costs $3 per pen to produce the next pen, so that would be just $3. $3 is the rate of change. All right, let's go to page 163 in your book. Marginal revenue is the rate of change of total revenue per unit changed in sales when the level of sales is X items. So it's just the derivative. Notice that it says, you might want to underline this in your book, as with marginal costs, marginal revenue is an approximation of growth or decline. All right. A manufacturer has determined that the piece of certain custom-made tables he produces can be determined by, so this is price. Notice that price is also called the demand function, where X is the number of tables produced and sold. Let's find the revenue function. Well, from our formula sheet, we remember that revenue is price per unit, price per item times the number of items sold. So the revenue is going to be X times D of X, which is X times 117 minus X over 4. Simplifying that, that's going to be 117X minus X squared over 4. And that's revenue. Determine the marginal revenue when 16 tables are made and sold. Well, that's the rate of change of the revenue when 16 tables are sold. All right. So R prime of X is going to be 117 minus X over 2. Quickly doing your algebra in your head. The rate of change of the revenue after 16 tables are sold is 117 minus 16 over 2. 117 minus 8, which is going to be 109. So the marginal revenue is $109. After the 16th table is sold, then the revenue changes by $109 per table. So my revenue is going to increase by $109 after I sell that 16th table. Revenue is changing by $109 per table. All right, marginal profit is on page 164. So in our book, page 164, the rate of change of profit per unit changed in sales when X items are produced and sold. So it's the rate of change of profit. So here we go. Next page. In the previous example, the manufacturer had a cost function of 225 plus 2x squared and a revenue function of 117x minus x squared over 4. Find all possible break-even points. All right, well, break-even, you remember, is where your cost and revenue, where your cost and revenue are the same, so that you will break even. Okay, so this is where the cost equals the revenue. So get your calculator out and go to your y equals key, and let's type in the cost function. And let's type in the revenue function. Let's think about our window. Well, this y-intercept on the cost function is 225. And I know this is an upside down parabola, so I might go kind of big here. Let's say my window, my X-Men, I'm selling items. So I'm going to go from -5, just so I can see my y-axis, and I'm going to do a max. Since I'm selling items, let's do 100, and then my scale will be 20. Y-min is -10. Let's just keep that there. And y-max, like we said, this y-intercept's 225, so I think I'm going to let my y-max be 250, just so I can see everything. And my y-scale then, let's make it 50. So type in all those numbers for your window and graph. Ooh, so he's way up there. And ooh, he's too let's go from, let's let our x max be, well, let's see if we can bring that down a little bit. Let's let it be 80 and let our scale be 10. And maybe I should go a little bit higher here. Let's go to 300. And where's my other one? See if I, oh, he's way up here where they intersect. So let me see if I type these in correctly.